Good day everyone. Today I'm going to show what I actually corrected on this system. It was a complaint of not coming up initially. So what I did was I removed this section off. I took this section off. I think there was a mix-up somewhere where they actually powered the system above the battery voltage. Okay, the system was actually powered with battery voltage, and I think there was also a reverse polarity along the line, so it actually damaged this unit. This unit is actually attached to the positive side of the MOSFET. That is the positive side of the MOSFET, which is this is the output section of the MOSFET. This is the output section of the MOSFET. So the positive side of the MOSFET, here we have this unit attached to that section to actually switch the incoming positive voltage from the battery to the MOSFET. So that is just what this guy is doing. It should, in case you see this unit, it can be detached. All right, it can be detached, but the risk for detaching it is you put a safety measures in place not to allow a reverse polarity between the positive and negative from incoming battery voltage. So if you are able to be on the safer side with that precautions, you won't have any need of replacing these units. Okay, so that's what this unit is doing. So this unit is taken off, all right, because there are resistors here which I could not figure out the value, and secondly, this chopper, I don't know the status of the chopper, which would took me another time for me to troubleshoot, and I have so many other jobs actually to handle. So moving forward, okay, I haven't done this, taking the positive straight direct to the MOSFET, and the system was powered. I found out that the system was actually showing low battery. The battery was actually 24 volts, but it was showing low battery. So when you have a system like that is showing low battery, is for you to do what we call battery calibration. So you actually do a resistor calibration in the absence of this connection. All right, in the absence of this connection, you don't need the voltage at that period. You don't need the voltage to do that. So what I did next was to trace. You see the system actually. Let me just give you a brief flowchart of how this control card, all right, sensed the battery and also was able to power the MCU. This is the main microcontroller. All right, now when you have a battery in, okay, the battery flow through this section to this board. All right, the VCC and the VDD of the battery flow through this board, through this cable to this board. All right, now when the battery voltage flow directly to this board, there is going to be a positive bias voltage. Okay, a diode will be used. The negative goes straight, but the positive won't go straight. So if you study what they call forward bias, in a forward bias you have the anode connected to the positive, and you have the positive at the output of the cathode. So that is exactly what is done here. All right, that's exactly what is done here. I don't know if you can see properly. So that is exactly what is done here. So the positive of the battery didn't go straight, all right, it's passed through this diode. And what is the advantage of that is to ensure that when you have a battery voltage reversed, when you reverse, you mistakenly, all right, if you're not conscious of the battery connections and you mistakenly reverse the battery voltage, it might place a detriment consequence on this MOSFET section here. But on this control card, the inrush won't come in because this diode will not allow a negative to flow from the anode. So there won't be any consequence on this control. Actually, there won't be any problem on this control board. So that is the beauty of having this diode here. I think MOSFET actually had that section to their board also, most power. So let's move forward. Okay, so when the positive pass through here, from here the positive goes straight to the, all right, to the MOSFET, to the drain of the MOSFET. So the positive latch here straight to the positive of the MOSFET, all right. But it passes through this coil, from this coil, the output of this coil, then it comes through the MOSFET here. This is the SMPS section, all right. The purpose of the SMPS is to have the battery connected to it and have independent outputs from the battery, independent outputs, which is going to be negligible from the main battery voltage. So you'll be having what we call auxiliary voltage, like 12 volts, 5 volts, 15 volts, and so on and so forth. So it's going to be coming out from this SMPS. From the output of the SMPS, it passes through the regulator that provide the 5 volts and power the MCU. Okay, so that's just the brief flowchart of how this board is powered. But it doesn't stop there. Okay, it doesn't stop there. All right, now the outputs, okay, of the DC that is biased, the positive and negative, all right, is connected right here. Is stored in this capacitor. It is stored in this capacitor, all right, before it now goes to this SMPS. Now if you take your positive and negative, you take a probe and maybe want to do calibration, we took, you know, a test directly, instead of going here, instead of coming here, we take a, instead of coming here, all right, not, we don't want to disturb this section, but we want to just take a direct supply 24 volts directly to this section. So we can do that on this capacitor, all right. So we'll take our positive and negative straight up from this capacitor and the system will come up. But something will happen on these particular units. You will not see the battery voltage on the screen. Okay, the screen will show you low battery. You will see the battery voltage. If you do that, you will see the battery voltage. All right, why? Okay, why? In the next video I'm going to show you why, all right, and what is the cause of the system showing low battery. All right, if you like this video, okay, please kindly like and share, comment. Then in the next video I'm going to show you how the system was able to sense the battery voltage so that it will display on the screen and show you the battery voltage. And don't forget, if the battery voltage is not being sensed, the microcontroller will deduce that there's a problem and it will not activate the MOSFET. All right, it will not switch the MOSFET to drive the transformer and produce an output. All right, to produce an output from this socket. So in the next video I'm going to show you, okay, how this system was able. Right now let me plug it in and let me show you so that you can see it's actually sensing the battery voltage. Okay, so you will see now that it's sensing the battery voltage and it's working properly. Okay, so you have a power indicator here if there is a power to the board, right? If the SMPS is okay, you must have this indicator light on. So let's see what the display is showing on the screen. Okay, you have a 220 volts, all right. You have a 220 volts. Then again, there is still another error to be corrected. You can see the inputs. The input is showing, okay, the input is also showing 220. Okay, so the input and the output is not supposed to be showing, all right, the input and output. So this is a problem. Okay, we're going to figure this out. I'm going to figure this out. I'm going to solve this problem, do a video to show you how this problem will be sorted out. All right, in no case, okay, in no case must inverter tested on battery should be showing output on the input side. All right, this output should be reflecting on the input side. Should no case anything of such should happen, there will be a submerge and there will be a collision, and that can create a serious feedback so on the MOSFET. So let me just see what I was able to correct first. Okay, you can see the battery voltage and the system is outputting. So I'm going to show you in the next video how I was able to correct. All right, I was able to correct the battery voltage, which is 25. All right, this is 25.9. okay, so initially it shows 6 volts. It shows 6 volts. So this time around the DC side is corrected, working properly. All right, there is no load, and then this is an error. Okay, this is an error. Whenever you see this during a battery test on any inverter, don't engage input to it. Don't engage input to the system. Okay, don't engage input to the system. So I'm going to correct this in my next video. I'm going to show you how I was able to correct this, do this correction. But right now I was able to correct the battery voltage, which is pretty working well now, and is showing the right parameters for the battery. Okay, so thank you, stay tuned for my next video. I have 2 videos covered. The one that will show you how I was able to correct the battery voltage. All right, then the next video is the third one is the one that will show you how I was able to eliminate the inputs that is showing right here without inputs connected to it. Okay, thank you.